Alright, welcome now to a video on the surface area of pyramids and cones. So we just did prisms and cylinders, so now we're going to do pyramids and cones and add those to our 3D solids. So for pyramids, we're going to do it two ways, kind of like we did with the prisms. We have the formula way, which says that surface area equals area base, that's what capital B is, plus 1/2 times perimeter times slant height. That L is slant height. That's the slant height of your pyramid. And the slant height is, if you look at one of the triangular faces, this is your slant height. It's the height of that face. So that's the slant height. Or we can break it apart into the separate shapes and add those together, just like we did before with the prisms, but we can only do that when the base is equilateral. You only want to do that when the base is equilateral because it may not give you the slant height for all the faces. So, only do that whenever it's an equilateral base. So, I'm going to do two examples here, and then I'm going to have you do an example on your own, and whichever way you like. So, here we have a pyramid with not an equilateral base, so we're going to do the formula, and that is surface area equals area base plus 1/2 perimeter times slant height. So we got to figure out what shape is our base. Our base is a triangle, which means that the formula for area of a triangle is 1/2 times base times height plus our 1/2 perimeter times slant height. And again, I highly suggest in place of area base, you put the formula and then you start plugging numbers into that formula. Don't just start to plug numbers in. You'll get stuff mixed up. It's always better to be safe. That way you don't lose some points for something silly like that. So, the base of our triangle, remember the base and the height of a triangle where there's the right angle. Well, right here's our right angle. So that looks like it's going to be, the base is 12 and the height is 6 plus 1/2 times the perimeter. If you add up the sides, 18, 18, and 12, you'll see that you get 48 times the slant height, which is 8. And then we plug this in the calculator, we get 228 inches squared. Now here on the right, we have a regular polygon as our base. It's a pentagon, so we have a pentagonal pyramid, which means that it's equilateral. So we're going to break it apart. So we're going to break it apart into the bases and then add together all the faces. So the nice thing about this is we can just do area base formula. And for a pentagon, it's 1/2 times, not base, times apothem times the perimeter. And then we're going to add the faces. Now the nice thing about these faces is that since the base is equilateral, all the faces are going to be the same area, equal area. So we got to figure out how many faces are there. Well, there are 5 faces, and then we're going to multiply that by the shape that they are, the base area. And since they're all going to be triangles, it's all going to be 1/2 times base times height. And in place of this height, I'm actually going to put, well, that's a really big eraser. I'm actually going to put an L there because that's the slant height. We're going to use the slant height of the pyramid. We're not going to use the height of the pyramid. I want to use the L there so you don't get it confused. So this is going to be 1/2 times the apothem, which is 8.9, times the perimeter, which is 13 times 5, plus 5 times 1/2 times, I'm going to move this down since we're getting a little bit crowded. So we're going to add the 1/2 times, oops, I forgot the 5. 5 times 1/2 times the base, which is 13, times the slant height, which is 21.9. And if you add those together, you'll see, you multiply and then add those together, you see you get 1,001. And then I didn't have a unit there, so we're just going to call it units squared. So 1,001 units squared. Okay. So here is a triangular pyramid. The base is equilateral, so if you want to do the break apart, you can, or if you want to do the formula. So go ahead and figure that out now by pausing the video. Alright, and here are the solutions to that. I know I didn't tell you, but let's go ahead in this video and round everything to the hundredths place. So we get 187.65 centimeters squared, no matter which way you do it, which is good because it's the same shape, so you should get an equal surface area. So check your answer with mine, make sure I did it right, and you did it right. If you don't have any questions, we'll move on. So now we're going to do the surface area of a cone. And just like with the cylinder, we're going to just use a formula because that's the easiest way to do it. So we have the surface area of a cone equals area base plus 1/2 times circumference times slant height. Now, the base is a circle, always a circle. So that means that in our formula we can change it into surface area equals area base is pi r squared plus we get 1/2 times 2 pi r in place of circumference times the slant height. We can change this formula one more time because our 1/2 and our 2 here are going to essentially cancel each other out. 1/2 of 2 is 1, so we can write this as pi r squared plus, since these basically get rid of each other, pi r slant height. And I just want to show you where this comes from in this picture here. So I'm going to take this cone, I'm going to break it apart. So we know the circle is our base. It's a really bad arrow, isn't it? There's our base. So if we pull that off, and then let's say we took scissors and we cut along our slant height. What that actually does is that creates something that looks like this. So here's our slant height, and then this right here, I'll change that to red, is actually the circumference of the circle. So what we are doing here is we're basically creating something that looks kind of like a triangle. Kind of like a triangle. So that's where that 1/2 came from in the 1/2 times C times L. Because if it's a triangle, it's 1/2 times base times height. Well, the 1/2 is always there. This would be your base, and this would be your height. But we replace that, and then we change that formula into something that's even easier to work with. If you can't really see that, and you want me to give you a better visual, let me know. I can create a visual for you. So, I'm going to do the problem on the left, leave you to do the problem on the right, and then we'll be done with this video. So, here on the left, we have our formula, surface area equals pi r squared plus pi times radius times slant height. So, let's just plug in some numbers. So we get pi times the radius squared, so 9 squared, plus pi times 9 times the slant height, which is 12. And again, we're going to round to the hundredths place, so we get surface area equals, we do that in the calculator, we get 593.761. We're rounding here, so we get our surface area to be 593.76, and then it's in inches squared, or it's still squared inches. So, go ahead, try the problem on the right. Note that that's the diameter, though. Okay, so there's my solution to that. Go ahead, check mine with yours, make sure everything looks good. After that, you're done with this video.